Hello, everyone. Welcome to this week's Echo Office Hours. I'm actually filling in. Uh, Duffy was originally scheduled, but he had a conflict, so I'm jumping in on short notice, and I'm going to be talking about one of the new features, the new capabilities showing up in the Cilium 116 release. Uh, some partial implementation of the Gateway API service mesh. But before I get into that, I want to start with recapping the news. Bill put out a new Echo newsletter, and there's some interesting things in there. And I think it's a couple of them are really, they're all really good, but he highlights a couple of important ones for the ecosystem that I think are worth a shout out. So I added that to the screen. And yeah, so he starts out and he highlights the big ones and the fact that the eBPF based scheduler is coming to the Linux kernel. It's a big change. It basically adds another kernel subsystem that will be extensible via eBPF. And I think if you read the down here, there's a link to the Linux weekly news article. Where is it? Yeah, there it is. So, whoops, I meant to add it as a new tab. Which sort of just to recap, but if you follow this, there's actually a lot of videos about this. It's been a multi-year discussion upstream, and it's finally gotten to the point where it's being allowed to be mainlined in the kernel. So I think I expect to see a lot of more interesting development around that. A lot of talks about that now that it's going and it's been outside in a branch for a while. I think multiple multiple people have been working on this and trying to push it forward. So that's big news. The other big news that he highlights is that Elastic has contributed their eBPF continuous profiling agent to OpenTelemetry, and OpenTelemetry has been on, I think, for like the last year, has been on a roll to make continuous profiling part of the OpenTelemetry's core proficiencies after metrics and logs. Like they're working on allowing you to attach uh, profiles to that telemetry. And my understanding is reading the backlog of information here is that Elastic actually promised to donate this as part of that effort, and we're now at that point, and that's actually great to see. So a new eBPF based profiling agent donated to OpenTelemetry. So that is something if you are interested in checking out. In fact, Bill highlighted another interesting profiling. It's sort of a how-to, uh, profiling libraries, VPF, basically, sort of the, sandbox proof of concept, a learning example that you can follow if the to get a feel for how these UPF profiling works. So I think that's a good one-two punch. You can read this one and get a if you don't understand how the fundamentals of profiling is working, you can read this and get an idea. There is a UPF example. I think he has BCC code in a repository. Yeah, I think he links to yeah. There's the code base for the whole thing. But this is a blog post that basically summarizes his own learning uh, based on how he thinks other things are doing the profiling. So, like I said, I think that's a couple of interesting one-two punch. If you want to learn about eBPF based profiling, this and then then you can tackle looking at the uh, the Elastic's donated eBPF profile, which I'm sure is quite comprehensive. So, having tried to read a lot of UPF code, I think you get lost in it unless you the simple examples of are good to read through first. It really helps understand how the more comprehensive implementations are doing the work they're doing. So I think that's the two big things. There's a lot in here, obviously, always. Uh, But I think that's what I wanted to recap on the news. Always check out the newsletter. Bill puts curates this and puts it out every couple of weeks, and which makes it easy for me when I have to jump in and do the office hours. Uh, I guess what I should say is after the news, there are two important things I need to shout out about. We've got two upcoming Cilium eBPF um, conferences. The first one is eBPF Summit, which is a virtual conference, and it's all about eBPF. So, and that is the paper submission is open right now through July, I believe. Yeah, I have it. I have a tab here. So, yeah, so through the 17th. And if you are working on anything with eBPF, this is a great way to submit the talk and get an audience of other like-minded eBPF enthusiasts and practitioners. Like I said, this is a virtual conference, so you don't have to travel there. So we've got lightning talk sessions now and 15-minute talks. So um, please think about that if you're working on something interesting in the eBPF space. Also, um, as part of the North America KubeCon Cloud Native Con experience coming up this fall, there is going to be a add-on event. I think like one of the day zeros for the Cilium plus eBPF Day topic. So this is now the opportunity if you want to talk about Cilium specifically. Um, if you have an interesting Cilium use case, or you want to talk about a feature you're working on associated with Cilium, you can submit to this. But you can also submit eBPF talks. So this is another opportunity if you're going to be at QCon North America and you want to talk about something interesting, EPF, you can submit here too if you want to do, I think, a longer talk than the virtual EPF summit that's coming up. So EPF summit is happening first, and then later this fall, uh, the Cilium plus eBPF day is happening, and you can submit to both if you're talking about eBPF. So I want to make sure I got that out of the way before I dive in to what I really want to talk about, which is the service mesh implementation of Gateway API that Cilium is adding in 116. So let me stop sharing that screen for right now, and I'll just go to my big face. So I know we had an echo session, I guess maybe 2 or 3 sessions ago, where Dan and Christine, my teammates, talked about Gateway API use cases, and I don't want to tread over the exact same ground. I actually want to show you the fact that there's something new showing up in Cilium as an implementation. Because up until now, Cilium's had the Gateway API implementation for Ingress, and uh, but at the same time, upstream, the Gamma initiative has been working on Gateway API for a service mesh. And I actually did a talk about this at scale, and I'm going to show you a few of those slides for those of you who haven't seen the talk to sort of set the groundwork for the demo I'm going to do. So let me get back to my browser because I have a cut down version of that slide deck to sort of set the stage. Um, yeah, so this is some cut down versions of my slides from the scale talk I did. This was at scale 21X. It was in Pasadena this spring, and I covered Gateway API sort of at a high level for the audience, right? Um, Including ingress and the experimental service mesh capabilities. But I'm not going to go through the whole thing here. I'm going to just uh, give you the highlights and focus on the east-west or the service mesh routing that you can do with Gateway API as it's an experimental feature, but it's under development, and there are multiple implementations actually out there now. And Cilium just grew its first part of its implementation. So, so just to recap, Gateway API is basically a redesign of Kubernetes ingress, and it's been informed by a lot of the challenges of the original ingress implementation. So it makes it easier for practitioners to pick up and make use of without a lot of brittle annotations for capabilities across different implementations. Um, but I think the really important thing for me, and the way I really grasp why Gateway API is happening and why it's so interesting, is because they're really taking a roles based approach and thinking about it in terms of, you know, if you're a infrastructure provider, what they have to do. If you're a cluster operator with enhanced admin access to the cluster wide facilities, what they have to do, and then you as an application developer who's working on a service or working with teams of people who are working on their individual service in a microservice architecture in a cluster, um, how do you make sure you can get your work done without having to constantly poke the cluster operator if you need to make a change to how your services are routing to each other or from outside to inside, right? So I think that's really the big concept here, not so much the implementation, but the fact that they're thinking really hard about roles, and as a result, what they're implementing is just easier to use in solving, I think, the real problems, right? The intersection between people and and technology. And so the big thing I want to highlight here amongst all the implementation details is the stuff for the developers, the stuff in yellow here. We have Gateway API has this concept of routes, and routes are what you're going to be interacting with the most as a developer. You basically get to say, I want to be able to take this part of the URL basically and route it to some service, right? Or some service backend. And what's really interesting is that these things are super durable, and so they can not just be attached to gateways, but for north south, which is the ingress into your cluster, but also attached to services, so you can implement service mesh features with basically the same language as you did for ingress, and that is exactly what the Gamma initiative upstream basically figured out. It's like, wow, we can use these things and collapse a lot of the complexity around service mesh implementations into these durable route resources. And the other thing I won't get into much, but I have to show it in the demo a little bit. Reference grants, which are an interesting way to basically allow teams working in different namespaces to get access to resources they need. For example, the I'm not going to show it, but the TLS certs are a thing that you might need to have access to, but from a policy standpoint, are controlled in a different namespace. So you can actually now have teams granting access to resources, and it's not just certs, but also you can grant access to basically say, yes, you're allowed to route uh, a URL into this other namespace that I control, so that different teams can control how things flow in the correct boundaries. So, and you're not always asking for the cluster operator to get in the mix there. Right. So I'll just skip over this. Like I said, the route resources are really what you care about when you need to interact with the your other teams, or even want to control how users are routed or requests are routed across your services. If you're doing something like um, internal versioning of services, and while it starts with HTTP routes, and I will only be showing that because it's the simplest thing, upstream is actually working on this concept, an experimental nature for other possible protocols, right? So HTTP is what Ingress started with. It was really about web services, right? So that's where things started because that's also the biggest use case. But there are growing use cases for uh, GPRC and just bare TCP and even UDP routes. So, and what's interesting is that because Gateway API was designed to be durable in a certain way, or it makes it possible to use the same language and have the implementations work towards these other protocol supports. And it's something traditional ingress just couldn't do. And like I said, you this will eventually extend to service mesh, not just for ingress. So just a quick breakdown of what I'm going to show you in a demo using the Cilium Death Star service. I'm gonna be making use of HTTP routes and reference grants to basically uh, allow a outside request to flow into the cluster into the right services um, without a lot of complication. So this sort of just points out that the role division, even though I will personally be wearing all three hats here, I've actually already, when I get to the demo, I've already done the infrastructure provider bit. I've built my little kind cluster, right? I've I've created the gateway um, as the cluster operator, and I'll show you the resource for that. But what really I'm going to focus on is now we're just going to be just the application developers, and they need to make sure that the requests are routed correctly, and they have control of all of this inside of their namespace and not cluster wide and not infrastructure provisioned. So I've skipped a ton of the original slides because I don't want to focus on the ingress, the north-south routes into the cluster today. I want to actually play around with the east-west implementation that we have now in Cilium, and I think the point here is that like the gateway stuff has reached sort of a stable GA um, point, and and there are multiple implementations now that of Gateway API, not just Cilium's. Cilium's had it, I think, through the 115 cycle. It's been available. Um, so what I'm really interested in is the service mesh binding, which is the east-west routes, and basically, you take the exact same route, and instead of attaching it to a gateway, which is in for the cluster ingress, you attach it to a service instead, and you redirect uh, flows so it doesn't go to the original services backends. You can go to other services backends, which is uh, exactly what. So you get the same capability at ingress, but now inside the cluster. So when you call the service, you can get um, redirections or traffic splitting um, or I guess header injection, the same things that you do at ingress. Now you can do with the exact same route. So taking Surface Mesh into Gateway API. And when I gave this talk, Cilium did not have an implementation for this at all. And I'm going to show you 116 release candidate has an initial implementation, and I'm going to show it off. That's what I want to get to. So just just so you have a good picture of what's going to be going on, I basically am going to take take the Death Star service, right? And well, actually, this is a wrong depiction, but of what I'm actually going to show. But the idea is I'm going to take a service and I'm going to basically do a traffic splitting. So you can go to a V1 or a V2 based on, I'm going to use a header to turn this on, right? I'll show you in the route. And I'm going to show you an ingress route first. Uh, and then I'm going to show you the east-west service mesh version of that, which is just a small change in how you attach the route. Right. So like I said, I'll be able to do a traffic splitting example. This is what I'm going to focus on in the demo. So, and I want to think about this is the way to think about it is, services are actually a construct inside Kubernetes. And there's a front end endpoint that's usually like a cluster IP, and there's a usually a set of backends, right? Not all services have backend pods. There are some headless services. In fact, the Cilium gateway API itself is actually doesn't have backend pods. It gets Cilium knows to redirect that into the Envoy proxy that actually implements the route rules. Um, but the idea is that a service basically has backends and front ends, and the cluster API, or sorry, the gateway API is able to uh, get in between those and redirect to different backends. So you're still talking to the same front end, but now gateway API internally and different implementations will do it a different way, right? But ultimately, uh, it will redirect to other services backends. So in an ingress gateway API's ingress, it sort of looks like this, where the external client hits the gateway, and then the HTTP route will basically direct to a service backend. Whereas a load balance service, the external client would be talking to the front end, right? In a service mesh implementation of gateway API, the HTTP route basically intersects from a service call front end and then decides to send it to another service. So you're basically short circuiting what the original uh, flow from the front end to the back end of a service, the different facets. You're basically redirecting that flow. So that is sort of a cut down version of my talk that I gave at scale, and I want to now actually play with Cilium's implementation a little bit. Let me get out of here. Quick question from Conrad before I go. No, the gRPC routes are not supported yet. This is actually a partial implementation. Uh, it is in the document. Let me show you the documentation real quick. Uh, in the latest, and this is the development documentation for Cilium because this is the unreleased release candidate for 116. But you can always go to latest to see what the pre-releases are or the release candidate documentation is. And since I think we just entered feature freeze. That's why the first release candidate's out. Um, Now it's just bug fixes, but if you look here at the latest service mesh, it goes over what's supported and what isn't. And right now, uh, it just supports HTTP route and just the producer route. There are two types of routes that upstream gateway API uh, has, and the consumer routes allow you to do routing across namespaces, and the producer routes is you have to attach inside of namespace. So, it is a partial, but I am super excited to see it at all because I really want to see this go further inside Cilium. So I'm going to show you uh, real quick a producer route and show how it interacts. So hopefully that answers your question. And I'm going to um, stop sharing my screen. But like I said, this is a partial, and it's everything upstream in Gateway API and around the service mesh implementation is active development. So um, I expect things to change a little bit over time, but certainly Cilium is going to grow more uh, support for this. But we got to start somewhere, right? And I think the big thing to note is that because the way Cilium works right now, this was the easiest thing to implement because Cilium's Gateway API, from an ingress standpoint, you're basically redirecting into the Envoy proxy that's running one per node in Cilium, right? So, and the original Kubernetes ingress implementation and the Gateway API ingress implementation do that, right? For Gateway for Cilium, and so this is doing the same mechanism on ingress now for a service, right? Instead of ingress in the cluster, it's ingress from a service. And because all of that implementation was there, I think I, I'm not going to put words in the mouth of developers, but I think this is probably the easiest thing to implement. The consumer routes, I think, are a little harder because I think there's going to be some work to uh, redirect that in the onboarding proxy on egress from a service instead of ingress from a service. So, uh, but we got to start somewhere, right? And so, uh, this I just want to show you what's working right now, and hopefully, I get people encouraging to play with the release candidate and file some, you know, test in different environments and file some bugs. Testing is always appreciated. That's my other thing. I probably should do an office hour just on feature matrix testing and how valuable that is in from people in the community because the automated test can't the Indian test really focus on a certain amount of the feature space and um, the outside testing really helps work the corners. So let me switch over. I gotta make technology do what I want. uh, I gotta switch over to my terminal. So I am on the terminal now. I probably should hide my face because I'm going to run into problems here. So although I gotta turn off the banners. Hold on. Okay, that's better. Whew, okay. You really need to be able to see the prompt. Okay, so I'm going to be talking while I'm working in the terminal. So like I said, uh, this is a set of demo environments actually put together for scale. And I have a whole I've been playing around. I have a repo show you. It's my If you go on GitHub, there's a whole bunch. I just been throwing stuff in here now, different environments, different branches as I try to build more on the same thing. I've actually been doing a lot of testing now using these environments, sort of a baseline for me, so I can play with, like I said, different features and seeing if there's a problem when I turn multiple things on and how they interact. So let me yeah. So the big thing here is that I'm actually using Cilium's L2 load balancer concept to give all my load balancer services are uh, an IP address that I can then communicate with from outside the cluster. So just show you real quick. Here's my L2 announce policy. I'm just saying, hey, use the load balancer IPs. And here is my load balancer. Whoops. And this is, like I said, from a role standpoint, this is set up at the cluster admin level, right? So this is stuff I already pre-did uh, just as part of spinning up the cluster. So and it basically says, all thy load balancer services are going to get an IP address in this range of 100 to 200 in this subnet, right? So, and what I did, if you spun up a whole bunch of stuff initially to seed this cluster. It's an expansion. If you've run through the documentation for Cilium, the Death Star service is the tutorial, and I've expanded on that and imagined what an empire full of deadly weapons would look like. Not just the Death Star, Omega Frost. I have a rebel scum namespace. Not just the Death Star. So the Eye of Palpatine, which is one of my favorite super weapons. So let me show you everything I have set up right now. And whoops, they all have, the load balancers all have external IP ports. I've also set up uh, a Cilium ingress and a Cilium gateway for a couple of things. So I have a Death Star gateway set up. I have a Death Star ingress because, like I said, I was doing for scale. I was setting all this up so I could show you the differences, but I'm not going to focus too much on all of that. I'm just showing you what I have set up. So let's start with my gateways. What do I have for? Well, let's just look at the Death Stars. Let's just look at the Death Star namespace. Services, right? So here I have a Death Star load balancer service. Actually, I've given it an external IP address, so I should be able to communicate with it. This is from memory. Oh, let's see if I can do this. 68, 228, 101, V1, West landing. Yay, it works. So now if I also attempt to use the gateway from outside 107, it doesn't work because I don't have any HTTP routes defined, like none. So I can get to the Death Star service itself because I've given it a external IP address as a load balancer service, but I can't. And even though the gateway service for the namespace Death Star, let me show you that resource, the Death Star gateway. So this is the gateway I set up for the Death Star namespace, and it's listing on port 80, and it's saying allow HTTP routes from the same namespace. So basically, I can't attach to this without from outside the Death Star namespace without special permissions. This is all the gateway API ingress stuff. I'm just setting the stage so I can then show you the east-west service mesh. So this is all. So right now, this is all capability that exists in Cilium 115. I'll note when I pass the boundary into Cilium 116. But just to show you Cilium status. Whoops, I should do Cilium version. I'm running 16 release candidate 0. Yay. So I will be able to do the east-west stuff. But let me just get the baseline gateway working because I'm going to transition that HTTP route into something else. So let's start with the Death Star simple HTTP route. This will just get the gateway working. And all this is doing is saying, yes, attached to the Death Star gateway, and also attached to the infra gateway. But I don't want to talk about that at present. I just focus on this. In fact, I should have just deleted that to make it less confusing. And it says, match every path. Basically, I'm just using a path prefix, and access denied. So that will basically black hole because there isn't a service called access denied. But specifically for the request landing, this will actually go through and go to the service named Death Star, right? So if I do now, if I go back and do a landing request, it works. But also more interesting, if I do, because I have that black hole rule that goes nowhere, that just returns nothing. If I do this on the service, though, it gives me a 404 because it's actually connecting. When I connect to 101, just to go back. So not Death Star. When I connect to the 101, I'm actually connecting directly to the front end of the load balancer service, right? When I connect this 107, I'm connecting to the gateway, and it actually has the HTTP route rule there, right? So there's a difference in how they handle that missing path. In the case of the gateway, it's basically just getting black hole because it doesn't even connect to a service to return a 404. And in the 101 case, it actually connects to the service, and the service is going, nope, this path doesn't exist. So I set that up just so I can show you the difference of that. Yes, I'm actually talking the gateway, and there is a difference in behavior. So let's see if I can make a um, producer route. Well, let me show you. Let me show you a more complicated. I'm going to use this more complicated example. So here's the Death Star weighted because this gives me something to work with. So the idea is the Death Star. This time I'm gonna replace the HTTP route with something that allows for traffic splitting. So, and it's actually going to cross a namespace and go and talk to the landing requests, versioned landing requests in the traffic control namespace. So the idea in my demo I set up at scale was like, hey, we want to centralize landing request service for all these super weapons instead of just the Death Star. So let's have a team build that, and they have versions of that uh, service, right? And then let's let's see how we can traffic split, right? Or redirect different services into that, right? And and that's uh the ultimate goal of the gateway API service mesh implementation is to be able to do exactly that on a fine grained level. And I'm going to show you the piece of it that Cilium has implemented in the release candidate, which is just the producer route. So we'll start here as a baseline. This is attached to the Death Star gateway, just like before, but I'm now going to use headers. I'm going to match on headers, and based on what the header value is, I'm going to send it to different services other than the Death Star service. So let me put this one in, and it should replace because I named it the same. In fact, let me show you. This is important. This is how you know that you didn't make a mistake. uh, so and it actually is attached to something. So if you look in the status for the HTTP route, it actually tells you what it attached to. And if you make a mistake, it'll tell you false. So the idea is that the HTTP, yeah, so the HTTP route was accepted, status true, cross namespace references are not allowed, ref not allowed. I can fix that in this case, right? So but that's important. I don't have the reference grant in place yet, so this isn't going to work yet. But you see that in the I wanted to make sure you saw that in the status. That's how you tell that your HTTP route was attached, and if there was a problem, it'll tell you. It's like so what it's saying is that I can't actually attach the traffic control services. Not allowed. I'm crossing a namespace. So Death Star Gateway parent ref is correct. Says that the service access denied is not found because it doesn't exist. And then it says the gateway info doesn't exist. That's fine. Um, those are non. Those are non. They are errors in my HTTP route, but they're not fatal. They're just because I'm not using those. But I just want to show you that that's how you tell if your HTTP route was correctly configured. The status will give you this information. It's super useful while you're troubleshooting to let you know what's going on. But so let me show you now that that's in place because it replaced my previous simple one. If I go now back to the landing request, this doesn't work, and it doesn't work because I don't have the reference grant in place, right? So let me show you what the reference grant does. So the reference grant somewhere in here, yeah, traffic control reference grant. So what it's saying is the reference grants basically exists in the traffic control namespace, and it's saying, please, I will allow HTTP routes from the Death Star namespace to reference the service, the landing request service v1 and landing service v2. So this is basically the traffic control namespace developers, the people who have access to that namespace, going, yes, I agree to allow HTTP routes from the Death Star gateway to reference my service. And I don't have to deal with RBAC. I don't have to deal with cluster admin rights. This is just between teams, right? So once I implement this, and like I said, I'm wearing multiple hats, right? But the idea is that in a real production environment, everybody gets their own namespace and there's a policy between them, right? Now that I have this reference grant in place, what used to not work works. And you'll notice that the I made sure that the response tells you exactly which service I'm talking to. This is a variable. I actually had to edit the Death Star or the Star Wars Docker container that we use in our documentation, so I could make this a tunable. So it's not always just successful landing requests. So if you show you, I can show you. Yeah, I have a. I edit it so it takes a environment variable. So I'm just using the same Star Wars image, and I'm just changing the landing response, so I know which backend I'm talking to as I do all these reroutes, right? So that really helps in the demo, knowing it's working. But right, so this is uh, I got it working with the reference grant. Now let me actually get the traffic splitting working. Let me go back to the what was it, Death Star weighted. Yeah. So I'm making use of the header X request ID. And if I use the value alternative, it actually redirects the landing request to. And if I use the value weighted, it'll do traffic splitting 50/50. So if I do this, X, I already forgot. What? I already forgot. That's how my brain's going. Almost. Sorry. Hold, please. Hold, please. It was X request ID. Got it. So header X request ID alternative. This should now be V2. Yeah. And then if I go back and just look at the load balancer, it's going to the original Death Star backend, right? So if I use the load balance service, that's not behind the gateway, so it's not using the HTTP route. I don't get the behavior. So put that in there so that you could see the behaviors changing, right? So, but because I have this HTTP route that's able to match against this header, I can reroute to the V2 landing request. And then if I do weighted, I should get traffic splitting on a roughly 50%. So 2, 1, 1, 2. Yeah. So everything's working. And that is not the thing I wanted to show you. It's just the baseline, right? So let's see if I can make this happen in an east-west scenario. So I'm going to move, instead of working in the Death Star namespace, I'm going to work in the traffic control namespace. And this is where I have the two landing requests, V1, V2. So I'm going to take, I've already sort of set it up so I don't have to fumble and typo for 15 minutes. I'm going to take that weighted, uh, Death Star weighted, and turn it into a weighted producer route. And it's a small change, right? It's a very small change. It basically said, instead of acting on the Death Star service and the Death Star namespace, I'm actually acting on the uh, Then you request V1 service in the traffic control namespace. And that's the big difference. Simply attaching the same rules, right? Um, to a service instead of a gateway. And so this is a bit of a this is pretty obvious. This is the name of the HTTP route. It's going to be in the TC namespace. Now the parent ref, instead of being a named gateway, it's a named service. Port 80. This is the thing that tripped me up. Like I had to actually read a little bit. Because by default, these parent refs assume the gateway API group. When you're referencing a service, you have to do something here. You can't just leave it blank. I think, and I actually checked upstream um, in the CRD for the HTTP route. There's a comment about this, and you have to explicitly go blank or core because Kubernetes or services are a core API service. So you have to either set the group explicitly blank, which will then default to core, I think, or explicit to core. And this is going to get over time more complicated because I think the idea of references and reference grants like this is probably sounds like it's getting get picked up and used more widely. So this is something you have to watch for because I think Gateway API is sort of the first big external API like this. But there's a lot of things, right, that are going to be in their own separate group, and you're going to have to start referencing the groups. So it's something to watch out for. It basically uh, caused a problem for me. That's why I had to look at the status. In fact, you know what? I'm just gonna break it and show you. I've got a couple minutes. I will go through my entire process when I was originally playing with this last week or this earlier this week when the RC came out. So if I just remove this group, it does something crazy. So it's a demo. If I do traffic weighted producer, get HTTP routes, right? Just to show you it's uploaded, right? I've got the Death Star original one I was playing with. Now I have this one in the traffic control. And if I get it again, and why did I name it so long? TC, you'll see the status. There is no status because it wasn't actually attached to anything. Because it was trying to attach to a service in the API group for the gateway API, and it doesn't exist. So it just doesn't happen. So, but if I add this back, and I'm showing you this because I guarantee you, if you play around this, you're going to hit this and you're going to scratch your head. And it's really important to check the status of these things. If I apply it now I have a status, and it's saying that my parents, uh, you know, so the conditions like it's an accepted route, uh, the service reference is valid, um, and it's attached to a service in the same namespace. So once you get this information about accepted, then it's active. So what does that mean? Um, it means that I should be able to interact with this. So let me get services again, the namespace TC. And this only applies to the V1. So I'm going to service, so I should see a difference in behavior between V1 and V2, right? So I'm going to not use the external IPs initially. I'm going to try to use it like an internal service. So I got to find, I think I have my swing. Yeah. So let's see, exec TI namespace rebel scum and pod X wing. Whoops. I'm going to try to remember those IP addresses, but I can flip over. So I'm in the X-Wing, and I think, okay, so if I curl X post HTTP, and I believe I always mess this up, TC, that should be enough to do the DNS service name lookup inside the cluster. Let's, in fact, I should do V2 first because V2 was the one that was unmodified. Yeah. So I'm able to access, and then if I do one, cool. Now, if I attach the header, please work. It worked a few days ago. This, and like I said, I'm now firmly in the 116 release candidate feature right here. This is attaching to the service. Oh, I forgot the request ID, right? Yeah. So with the alternative, it goes to V2, and then if I go to weighted, yeah, it bounced back and forth. So I was able to now take what was only a gateway ingress concept, the HTTP route, and now I was able to use the producer route version of what Gateway API supports inside Cilium's implementation and do this for a service in a namespace. So, and this is just the first part of the support for this, right? And so now I should have access to the same capabilities in terms of route matching and filtering at the ingress, and as I do between services inside of a namespace. So now this traffic control team can use HTTP routes to basically um, take the service request and do whatever they need to it. So hopefully that makes sense. It's, I think I'm sort of at the hour. I'm going to flip off of this now. I just wanted to show you what it's just a new capability. 115 doesn't support the Gamma the initiative, the Gateway API's service mesh implementation at all, and this is brand new. It's a partial implementation. Let me get back to my face, and hopefully that's like I said, I think it's really super exciting to see it, and uh, oh, there's a question. So, in general, would you recommend using cluster IP services with API? Um, well, I think for the service mesh implementation, I think that's the most common thing is that you're never going to expose them as load balancer services, right? This is you're generally going to do this inside your cluster. But oh, I should show you. I meant to play with this. I haven't played with it yet because I've exposed all of these as load balancer, and that's just from a demo standpoint. I wanted to interact with them from outside the cluster too when I was doing my scales demo. And I want to see, I don't know what happens yet when I do that because I do have load balanced IPs for those request services. Does that route actually apply? I don't know what the intention is. I just want to see what happens. Uh, yeah, here we go. So let's do this. Well, let me get out of the X-Wing. So I've proved that it works from inside the cluster using the cluster IP address, right? The cluster internal address. Or in fact, I use the DNS name lookup for this, right? So um, if I get, sorry, my I had a I had a small window in the way. So let me get the services again. So this is the service that has the HTTP route directly applied to it, right? And I've already used this IP address by accessing the cluster internal DNS name. What if I use that address? So So if I go back in time and find a curl, instead of 107, it's 103. Let me do anything but that. This should just give me, and if I do alternative, it should give me 2, maybe. If the right, so alternative, and if I do weighted, it bounces. So even though I'm using the external IP for this service, I am. Oh, I'm sorry, I wasn't sharing the screen. Let me go back. So even though I'm using the external IP for this service, I'm able to actually get it to respond to the HTTP route. So it's not just the cluster internal IPs. When you attach this to a load balance service, it actually will respond to the external IP address as well. That's interesting. So it's basically a way to, I mean, it's acting like ingress, but it's not ingress, right? So, but I don't expect people to use it this way, right? I expect you to use the service, the east west capability for cluster IP services. Um, and I guess for completeness, I can change this to cluster IP services and just show you, right? Might as well. All I can do is I can just break things, right? So if I do L request, let me just change this to a cluster IP. And since I have, where's my second one? Oops. Change this to a cluster IP. Because this shouldn't matter. In fact, this should be what you would mostly do. Right. So now they have no external IP. But if I go back into my X-Wing pod, I should be able to curl HX request ID alternative post HP request v1 TC. Yep. So so yeah, so that all makes sense. That's just for completeness, right? So I was just doing the load balancers specifically because I wanted to access them from outside the cluster while I was demoing some things. So yeah, so hopefully you saw that. I did fix my screen for the last one. And I think that's what I wanted to show. Like I said, this is as documented, this is a partial implementation and the upstream is constant, it's still moving. It's I think they're I think they're still trying to figure out some of the interactions. Oh, are there docs for playing with the RC? Yeah, there are absolutely. If you go Oh, am I there now? Wow. Sorry, I lost, I somehow lost my, the web browser that was attached to the streamer. So I almost got through this without a technical difficulty. Let me go back to the docs page. Just want to show you. So you go back to the docs page here. As long as you can always specify in the docs the latest pre-release or release candidate that's active, and that'll give you a version of the docs. So when you're doing testing of the pre-releases or the release candidate, instead of getting the version that is uh, just stable, or you can always specifically ask for uh, the currently active pre-release or release candidate version. It won't be in the pull down menu on the side here, because that's meant for, we don't want to confuse, obviously, like regular users, but testers. If you know you want it, you can put it in the and ask for the specific documentation that is matching this release, because this version of the documentation will become the release documentation for 116. So please test the guides in that as well, um, and that's always useful. So I think I want to end it there. Hopefully that was useful, and you will be playing around with the Gateway API. And if you find a problem that's not documented as not being implemented yet, please file an issue, so we can collectively work on getting this fully baked in Cilium. Hopefully in 117. I mean, I can't make promises for developers and their time, but it would be great. It would be great to see this fully baked. Like, even that is super great to see. So thanks again for coming. I think I'll remove my screen here, and I think that's it. I'll try to update the show notes after the fact, but I think we were at the top of hour. So have a good weekend. And for those of you who may be at SecurityCon in Seattle next week, maybe I'll see you there. And I have a talk, and a couple of other talks. Duffy's going to have a couple of talks too. So, okay, that's it for me. Thanks for showing up. Bye.